Hi, in this video we will continue talking about extraction, but we will talk about something which is related to calculations related to extraction, which is called the partition coefficient KD. So we mentioned before that during extraction, compounds will be partitioned or distributed between two immiscible solvents. And we talked about that the partitioning degree depends mainly on the relative solubilities of this compound in both layers. We talked about the solubility of caffeine in dichloromethane and water, and I mentioned that dichloromethane is a better solvent for caffeine than water, and that's why it prefers to go to the dichloromethane layer. So we can, in extraction, we can always talk about something which is called the partition coefficient, which is KD, that gives us an indication about the distribution of a compound in both layers. So if I want to know the amount of caffeine distributed between dichloromethane and water, I have to look at the KD value, or the partition coefficient value, which is equal to the concentration of the compound in the aqueous layer or organic layer divided by its concentration in the aqueous layer. We can use concentrations or we can use solubility, and the units here are not important as long as they are the same for the organic and the aqueous layer. So we can divide milligrams per milliliter, we can use grams per milliliter. So as long as the unit for this here and this one here are the same, units are not important in this case. The larger the KD value is, the more efficient the extraction. So whenever you are asked to choose the best solvent for a certain extraction, try to look at the KD value. The higher the KD value is, the more efficient your extraction will be. So we can also write the equation in a different way. So we can express it in the form of the mass of the compound in the organic layer divided by the volume of the organic layer, and this is divided by the mass of the compound in the aqueous layer versus the volume of the aqueous layer. We will use this equation a lot in our calculations in the next slides. So and remember always that the mass in the aqueous layer is always equal to the initial mass of the compound minus its mass in the organic layer. Remember that multiple extractions with the smaller volumes are always more efficient than a single extraction with a larger volume. So for example, if I have the option to do 3 extractions with 20 milliliters, it's always better than doing 1 extraction with 60 milliliters. Yes, we are using the same amount of solvent, which is 3 times 20, which is 60 in both cases. However, as we will see later on in the calculations, that if we do the extraction 3 times, the amount extracted will be higher than do it at once using the same volume. So again, we will prove this by calculation later on. But for now, just keep in mind that multiple extractions are always better than a single extraction. So let's do some calculation problems right now. We will start with the simplest thing, which is calculate the value of the partition coefficient KD if the concentration of the compound A is 0.006 molars in the organic layer and 0.01 moles. So this is the simplest type of problems here. KD value will be equal to the concentration in the aqueous organic layer, which is 0.06, divided by the concentration in the aqueous layer, which is 0.01, and this is actually equal to 6, and this will be the KD value. So this is the simplest type of problems. This is another type of problems where we use the KD value in this case. So we are given 10 grams of compound A. So this is the initial mass, initial, which is equal to 10 grams. We're dissolved in 100 milliliters of water, so the volume of the aqueous layer is 100 milliliters. If 20 milliliters of ethyl acetate, so ethyl acetate is the organic solvent, which means that the volume of the organic solvent is equal to 20 milliliters. We're using extraction. Calculate the mass of compound A that can be extracted. So they want us to calculate the mass of compound A that can be extracted to the organic layer. So this is the unknown, which is X in this case here. And the KD value is given and it's equal to 8. So now we will just put the equation first. So KD value is equal to mass organic V organic over mass aqueous V aqueous. Now, the mass organic is the unknown, so it's X. Volume organic is 20 milliliters divided mass aqueous is, remember from the previous slide, mass aqueous is always equal to the mass initial minus mass organic, which is X. So this is going to be actually 10 minus X. So I'm going to put here 10 minus X divided by volume X aqueous, which is 100 milliliters. And this whole thing is equal to KD, which is equal to 8. Now we have to do some math here. So X over 20 is equal to 8 times 10 to the minus 6. So I'm just multiplying this number by this fraction here divided by 100. And in this case, X over 20 will be equal to 80 minus 8X over 100. So finally, we will end up with 100x. So I'm doing cross multiplication now, equals to 20 times 80, that's 160, minus 20 times 8, that's that's 1600. 20 times 8, that's 160x. Finally, if you solve for x, you would notice that x will be equal to 6.15 grams. And this is the mass of compound A that can be extracted if we use 20 milliliters of ethyl acetate. So you have to be familiar with the mass of this problem, but this is how you usually do it. And we calculated basically in this way the mass of the compound. Now we will do similar type of calculations, but we will compare what I talked about before, which is single extraction versus multiple extraction. So remember, let's say I have 0.5 grams of a certain compound and they are dissolved in 150 milliliters of water. If I used 150 milliliters of ether, which is an organic solvent, and the amount X of this compound which can be extracted to the organic layer, in this case, if you want to do the mass, do it by yourself. KD will be equal to 4. So this is volume aqueous, this is the initial amount, this is the volume organic. Okay, and if you do the mass, you will notice that X, which is the mass organic, will be equal to 0.4 grams. So the amount of compound A that can be extracted is 0.4 grams using 150 milliliters of ether. Now, if instead of using a single extraction, I decided to do this in a multiple extraction way. So what do I mean by multiple extraction? So again, we have the same amount, which is 0.5 grams here. We have the same amount of water, which is 150 milliliters. But now, instead of using 150 milliliters of ether, we just use 50 milliliters of ether. So 1/3 of that amount. Again, given that the KD value is equal to 4 in this case here, if you do the mass, you will notice that the mass of the compound in the organic layer will be 0.29 grams. So 0.21 grams will remain in the aqueous layer. Now, I open the tap here, I drain this compound, drain the aqueous layer, and now this is the extracted amount. This is what is left in the aqueous layer. Remember that our aim is to remove our compound from the aqueous layer, which contains our compound in addition to impurities, into the organic layer. So I'm going to take this Erlenmeyer flask, put it back in the separatory funnel, and add another 50 milliliters of ether, and again do the extraction. Again, if you do the calculations, and we will show you the calculations in the next slide, you will end up extracting 0.12 grams, and the amount of remaining is 0.09. Even if I didn't continue right now for the third extraction, as you can see here, after using 100 milliliters of ether, we were able to extract 0.29 plus 0.12 of our compound. And the amount of our compound which remained in the aqueous layer is 0.09. Whereas in the single extraction process, when we use 150 milliliters of ether, 0.1 grams were left. So as you can see here, by using multiple extraction 2 times only, using 50 milliliters of water, we were able to extract more. And even now, if you use an extra 50 milliliters to extract the remaining amount, you will notice that the multiple extraction is by far more efficient. So to summarize, a multiple extraction is always more efficient than a single extraction in extracting a compound. Now, what we are going to do is that we are going to prove this by calculation. So in the next slide, we are going to compare the numbers for a single extraction and for a multiple extraction process, and we are going to prove that multiple extraction by calculation is more efficient than single extraction. So this is the problem. Again, we have an organic compound B. It has a mass of 6 grams. So this is the initial mass. Actually, this is compound A. So the initial mass is equal to 6 grams mixed with 50 milliliters of water. So volume aqueous is equal to 50 milliliters. Extracted using diethyl ether as the organic solvent, given the partition coefficient is 6.5. And the question is, find the mass of A that can be extracted. So we are talking about mass organic, which is the X, which is the unknown, using 60 milliliters. So this is basically the volume of the organic layer, which is equal to 60 milliliters. So this is similar to what we did before, but we are going to use the numbers here to compare them with the multiple extraction process. So again, KD is equal to mass organic over volume organic over mass aqueous over volume aqueous. And this is equal. So mass organic is X, which is the unknown. Volume organic is 60. Mass aqueous is, again, remember, it's always in mass initial, which is 6, minus organic, which is the unknown, divided by V aqueous, which is 50. And this is equal to 6.5. Again, doing the mass again quickly, X over 60 is equal to 6.5 times 6x over 50. So 50x over 60, I've just moved this here, is equal to 6.5 times 6 minus x. If I want to simplify this, I will end up with so that's end up with 0.833x equals to, this is equal to 39 minus 6.5x. Anyways, so if you solve for x now, so by moving this here, this will be 0.33x plus 6.5x equals to 39. So 7.33x equals to 39, which means that x is actually equal to 39 over 7.33, and this is equal to 5.32 grams. So the mass of compound A that can be extracted using 60 milliliters of ether to the organic layer is 5.32 grams. Remember that this is the mass that can be extracted using single extraction. What we are going to do is that we are going to compare this number with the same process, but now instead of doing a single extraction, we will do 2 extractions using 30 milliliters. Okay, so at the end, the volume of organic layer which is used is the same. It's 60 milliliters, but we are going to use it over two extractions instead of 1. So we will prove by calculation, and this is going to be in the next video, that using 2 times 30 milliliters by calculation is better than using a single extraction using 60 milliliters.